Once you do that, you have a consistent feature set. You just do your normal text classification. You have negative examples, positive examples. Now these are vectors over your feature representation of DQ pairs. These are not individual documents anymore. These are document query pairs represented as scores. And you're going to be learning hyperplane, right? And you have target labels for it, +1 or -1, whether they were relevant or non-relevant. So now what is a weight vector in this case? We're going to take each document query pair, do a dot product with W, and that's going to be a score. If that's positive, we're going to classify it as relevant. If it's negative, it's non-relevant. But if you look at the dot product, the W transpose X, think about what it means now. W are the weights, and these XIJs, XJIs, so this is for the jth training document. It's not a document, it's document query pair. This is not a word, this is not a phrase, this is one of your features. So this could be a TF-IDF weighted sum, or a BM25, or an ARM3 score, or an anchor text score, or PageRank, or anything. So anything that you've computed, that we've talked about in the scores, becomes an example of XJI. And what you're doing is you're basically learning a weighted combination of them, and you're trying to put optimal weights in a way that would separate the relevant from the non-relevant as best as you can. And there again, you have your normal SVM formulation. What I'm adding here, though, is I'm adding the slack variables. So I missed them on the previous slide. Slack variables are when your data is not linearly separable. And in this case, it won't be linearly separable, right? Because you don't have a huge dimensional space anymore. You have a relatively small number of features. You're not talking about billions of features. You're talking about maybe thousands, right? So for all relevant pairs, you should have scores bigger than +1. Non-relevant, smaller than -1. Now, some of them will get misclassified, and that's what these size represent. These are the slack variables. And your minimization function now becomes, in terms of minimizing the number of things that I misclassified. So you sum up the size for each document query pair that you misclassified. This psi j has a non-zero value. And for the ones that you got correctly, it is 0. So you're minimizing the total sum of them, right? So you're minimizing the total loss, the total number of misclassifications that you did. And you know that that's going to have that form of a solution, and that's going to have the same form that we had on the previous SVM slides, right?